Good morning, dear students. My name is Ferhan Mazher, and today is 20th January 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying today is Physics 5054. It's Cambridge O Levels Physics. Today, we have set our hearts to solve a theory paper. We call it paper 2. And today, we have selected May June 2017 2 paper. This paper belongs from the zone 2 or the variant 2. Today in this session, we will be solving the section B of this paper. The section A of this paper we have already solved, and that video has been uploaded in my YouTube channel and you can watch that. Today, we will solve the section B, and the section B is comprised of question number 9, question number 10, and question number 11. So let's start today's paper. So section B, answer 2 questions from this section, answer in the space is provided. Question number 9. Figure 9.1 shows a man in a room looking into a mirror as viewed from above. So here, this is a room basically, and in that room, this is a man standing here, and there's a mirror in front of the man, and it's a plain mirror, and here you have the walls of the room. The man can see, let me reduce the size so you can see the whole thing. Okay, the man can see an image of part of the wall AB in the mirror. Point C is the point on the wall closest to A that the man can see by reflection in the mirror. This point is not marked on the figure 9.1. On the figure 9.1, find the point C and draw a ray of light from C which enables the man to see the image of C. On the ray that you have drawn on the figure 9.1, label the angle of incidence and the angle of reflection R. So these are the 2 questions which we have to do the construction work on that figure 9.1. So question number 9A, first and second part. Let me increase the size so you can see the whole question on the screen, which they are asking you to solve. So let me show you how this is done. So May June 2017, the section B. We are going to the question number, here we go, 9. So on your screen, you can see the closest point that the man can see will be the point from where the light from this wall, the point C will be that point from where the light ray will come and reflect from this corner, the very extreme right corner of that mirror. So what I will do, see this blue line, I have used that blue line. First of all, I have drawn a normal on that point. I have drawn a normal on that point. And then I have joined the eyes of the man with that point where you have drawn a normal on the mirror. And that blue line touches that mirror on this point. So with the help of the protector, I will check how much is the angle of incidence here. And the same equal to the angle of incidence, I will plot an angle of reflection on this side, and I will draw this line. So this line will cut the wall AB at the point C. So this is the point C. So hopefully understand how I have drawn this. So I have checked the angle of incidence here, and the angle of reflection will be equals to the angle of incidence. So whatever is the angle here, same angle I have taken here, and then I have drawn this line. So when this line cuts the AB, that is the point C. Then I have marked this angle as the angle of incidence and this angle as the angle of reflection. And this is the principle of reversibility of the light, that the path from which the light comes, on the same path the light goes back. Okay, so that's why I have put the arrows. Light is coming in this direction, light is also coming in this direction. So this is the question number 9A first part and the second part. Hopefully you understand that how we have done this. Okay, so let's go to the question again. So then he says, one of the characteristics of the image formed by the mirror is that it is virtual. Explain what is meant by a virtual image. Virtual image means that an image which cannot be captured on a screen. The image is not formed by the actual intersection of the light rays. The light rays appears when you look into the mirror, the light rays appears to be coming from the image, but in reality they are not coming from the image. So that image is known as the virtual image. So virtual image is an image which cannot be captured on a screen. It's a 2-mark question, and let me show you my answer. Okay, so here we go. So rays do not come from the image. Rays only appears to come from the image. Image cannot be captured on the screen. So these are the characteristics of the virtual image. This is virtual image. Okay. So the next part, the next question they are asking is, that was a 2-mark question. The next thing they are asking is, state one other characteristic of an image formed by a plane mirror. So the image formed by a plane mirror is virtual image. There are several characteristics of the virtual image formed by the plane mirror. For example, the image is laterally inverted. Laterally inverted means that the right of the object appears to be the left of the image, and the left of the object appears to be the right of the image. That is known as laterally inverted. So the one characteristic of the image is their image is laterally inverted. The second characteristic is that it has front to back inversion. Another characteristic of the image formed by the plane mirror is that the image formed has the same size as that of the object. Another characteristic is that the distance of the image from the mirror is equals to the distance of the object in front of the mirror. You only have to write one characteristic here. So let me show you my answer, and here in answer you only have to write one characteristics. So I have written that image is laterally inverted. Image is laterally inverted. Hopefully you understand. So that was question number question number 9, and it's question number 9, and it's A part. So this is section B, question number 9, A part. Its marking scheme is showing up on your screen. You can pause the video and you can check the answers which we have shown, which we have written, which we have discussed. You can compare my answers, your answers with the marking scheme. Question number 9, A full part marking scheme is showing up on your screen. So let's go to the next question and next part, I mean. So the next part is question number 9B part. He says light travels along optical fibers by total internal reflection. State 2 differences between the total internal reflection and reflection in a mirror. You see, whenever the reflection in the mirror takes place, the angle of incidence can be any angle. The value of the angle of incidence in the case of the reflection in the mirror can be any value. But in the case of the total internal reflection, the angle of incidence must be, its value must be more than the critical angle. That's the one difference. Another difference can be that when in the mirror, the light travels in the rare medium. The light travels in the rare medium before the reflection and after the reflection. But in the case of total internal reflection, light travels in the dense medium and in the denser medium before the reflection and after the reflection. In the mirror, in the reflection in the mirror, the light is traveling in the rare medium and is reflected from the surface of the dense medium. Whereas in the case of the total internal reflection, the light is traveling in a denser medium and is reflected from the boundary of a rare medium. So these are the differences. You only have to write two differences in the total internal reflection and the reflection in a mirror. So let me show you my work. Reflection in mirror, angle of incidence can be of any value. In total internal reflection, angle of incidence is always greater than critical angle. In reflection in mirror, light travels in rare medium before and after reflection. In total internal reflection, light travels in dense medium before and after reflection. Hopefully you understand that was a good question. He says question number 9b and second part. He says the critical angle for light traveling from the material of the fiber to air is 44 degree. Calculate the refractive index of the material in the fiber. So it's a 2 marks numerical, and you remember that formula: optical refractive index is equals to 1 divided by sine C. Refractive index, which is represented with the n, small n, is equals to 1 divided by the sine of the critical angle. So very simple. So let me show you. So n is equals to 1 by sine C, n is equals to 1 by sine 44. So just enter these values in the calculator, you will get 1.44. So the refractive index is 1.4. Question number 9b, third part. Light enters the optical fiber from air with an angle of incidence of 50 degree. Calculate the angle of refraction. Now we know the refractive index and we know the angle of incidence, and we want to find out the angle of refraction. You know, n is equals to sine I divided by sine r. The angle which is formed in the rare medium is always put in the numerator. So n is equals to sine I divided by sine r. So n value is 1.4, the sine I, sine 50, divided by sine r. So we will find the value of the r by this formula. So let me show you how this is done. This is a 2 marks numerical. Okay, so n is equals to sine I by sine r. 1.44 equals to sine 50 divided by sine r. So sine r will be equals to sine 50 divided 1.44. So enter this value in your calculator. So you will get 0.532. So sine will come to this side. It will become sine inverse. So in your calculator, you will write shift sine 0.532 equals to, and that will give you 32.13 degrees. So and that is 32 degrees. So the angle of refraction will be 32 degrees. Question number 9b and its fourth part. Optical fibers are used in telecommunications to send large amounts of data. Pulses of light travel at almost the same speed along a fiber as electrical pulses travel along a metal wire. State 2 advantages of using optical fiber rather than wires of transmitting data. You see, some of the benefits or advantages of using the optical fiber are that the optical fibers are lightweight as compared to the metal wires. Another benefit of the using of the optical fiber is that when we use optical fiber, the loss in the signal, the energy loss in the signal is less as compared to the energy loss in the metal wires. So in the case of the optical fiber and the boosters which are required to amplify the signals, the less number of boosters are required. It's a 2-mark question. Let me show you my answer. So here we go. Optical fiber is lighter as compared to the metal wire. In optical fiber, less decrease in strength of the signal as compared to the signal in the metal wires. So, my dear students, we are done with the question number 9. So let's open the marking scheme. Question number 9 and the B part is marking scheme is showing up on your screen. You can pause the video and take your time, read this marking scheme very carefully, because the reading the marking scheme, comparing the answers of the marking scheme and your answers, your teacher's answers with each other is very, very important. This is practice which will actually polish you for your exams. And your work will be of that standard that you get full marks in each part. So pause this video and take your time, read this marking scheme carefully. Question number 10. Measurements are made of the current in a metal wire and the potential difference across it. Figure 10.1 shows a graph of the current against the potential difference for the wire. So here we have a graph, and here on the y-axis, the current is represented, and on the x-axis, the voltage is represented, or the potential drop is represented. Remember one thing, that when you represent on the y-axis current and on the x-axis voltage, the gradient of the graph will be change in current divided by change in voltage, and that is equals to the reciprocal of the resistance. So the gradient or the slope of this graph is equals to 1 by r. Remember this thing. So the first question they are asking is, state the relationship between the current and the potential difference for the metal wire. Okay, so if you look at this graph carefully, this graph is an inclined straight line, and its gradient is constant and is positive. And in your mathematics, you must have learned that a graph between the two quantities, if it's a straight line, its gradient is constant and it passes through the origin. And that condition is very important, that the gradient, that the relationship between the graph between the two quantities is a straight line with a constant gradient. And if it passes through the origin, then we can say that the relationship between both the quantities is a direct relation. So we can say that the current and the voltage drop, they are directly proportional. Here you only have to state. So you will state that the current is directly proportional to the potential drop. Let me show you my answer. Current and the potential difference are directly proportional to each other. The graph is a straight line with a constant gradient and it is passing through the origin. So that's why we can say that current and potential difference, they are directly proportional to each other. Question number 10A, second part. He says, state how the graph shows that the temperature of the wire does not change in the experiment. You see, because the graph is a straight line, it has a constant gradient and is passing through the origin. that shows that the voltage and the current, or current and the voltage, they are directly proportional to each other, which means that they are obeying the Ohm's law. And when something obeys the Ohm's law, the physical conditions of that thing do not change. So it means that its resistance is not changing, which means its temperature is not changing. So let me show you my answer. Question number, okay, so here we go. Graph is a straight line with a constant gradient. So that shows that the temperature is not changing. This shows that this is obeying Ohm's law. When something obeys Ohm's law, its temperature do not change. Okay, so question number 10 and A part and its third part. Another wire of the same material has the same length as the original wire, but has only half the cross-sectional area. Compare the resistance of the new wire and the original wire. You see, this second wire, which we call new wire, its cross-sectional area is half the cross-sectional area of the wire number 1, or the original wire. So we know that the resistance is inversely proportional to the cross-sectional area. So if the cross-sectional area of the new wire is half the cross-sectional area of the original wire, the resistance of the new wire will be double, will be 2 times, will be twice the resistance of the original wire. It's a 1-mark question. And the last part of the question number 10 and A part is on the figure 10.1, draw the graph for the new wire. Okay, so it's a 1-mark question. So let me show you how I have done this. Okay, second wire resistance will be 2 times the resistance of the first wire, or you can say the new wire's resistance will be twice the resistance of the first wire. Okay, so now this is that figure 10.1, and you know the slope of this graph is 1 by r. So if the current, if the wire whose cross-sectional area is half, its resistance will be double. So if, because the slope and the resistance, the slope is equals to the 1 by r. So if for double resistance, the slope will become half. So in, for example, the first wire, the original wire, in 5 potential drop, at 5 potential drop, its current was 0.4. So at 5 potential drop, the new wire, the current will be 0.2. So this red line shows its gradient will be half the gradient of the first wire. This red line shows that wire. Hopefully you understand. So let's go to the next part. But before going to the next part, let's have a look at the marking scheme. Question number 10 and its A part we have done. So the marking scheme is coming up on your screen. So my dear students, question number 10, A part, its marking scheme is showing up on your screen. Please take time, pause the video, and read this marking scheme for question number 10, A part carefully. Confirm the answers written by me, confirm the answers which you have written, compare them with this marking scheme. It's a very, very important habit. Okay, so then the B part, question number 10, B part. He says 3 resistors are connected to a DC power supply as shown in the figure 10.2. The electromotive force, EMF, of the power supply is 6 volt. So the power supply is providing 6 volt. Here you have these 2 resistors, 20 ohm, 80 ohm. They are connected parallel to each other. Then we have this third resistor, which is 24 ohm, and it is connected in series. Okay, so with this loop, it is connected in series. Here they are connected in parallel to each other. So the first question coming up on your screen is a 2 marks numerical question, and this is question number 10B, first part. is calculate the total resistance of the circuit. So if you want to find out the total resistance of this circuit, so the process is very simple. First of all, I will find the equivalent resistance for these two. They are connected in parallel to each other. This is R1, this is R2, this is R3. So R1 plus R2, I want to find out this. Because they are connected in parallel to each other, so if you want to find out their equivalent resistance, R4, the formula will be 1 by R4 equals to 1 by R1 plus 1 by R2. And once I know the value of the R4, the combined resistance of these two, that will be kind of connected in series with this one. So R4 plus R3 will give me the resistance of the whole circuit. It's a 2 marks numerical. Let me show you how I have done this. So question number 10B, first part, first portion. He says, here you can see I have named them R1, R2, and R3. 20 ohm and 80 ohm because they are connected parallel to each other. So I want to find out their equivalent resistance. Let me call that R4. Because they are connected in parallel, so I will write 1 by R4 is equals to 1 by R1 plus 1 by R2. So 1 by R4 will be equals to 1 by 20 plus 1 by 80. So in your calculator, you will enter 1 by 20 plus 1 by 80 equals to, and your calculator will be giving your answers in the decimal. Convert them into fraction by pressing, you will find a ABC button or SD button on your calculator. If your calculator has ABC button, just press that and it will convert the decimal fraction into a simple fraction. So I will press that and I will get 1 by 16, and then I will cross multiply. So R4 will be 16 ohm. Once you know the combined resistance of these two, that will be in series with this R3. So the R equivalent, which is the resistance of the whole circuit, that will be equals to the R4 plus R3, and that will be 16 plus 24, and that will be 40 ohm. It will be 40 ohm. So the total resistance of this whole circuit will be 40 ohm. Hopefully you understand. Okay, so let's go to the next part. He says, so we are done with the first part. Second part is the current supplied by the power supply. We say the current coming from the battery. So the whole resistance of this whole circuit is 40 ohm. The EMF is 6 volt. So how much current will be coming from the battery? And that's the question. So let me show you. The current coming from the battery can be found by the formula. You know, according to Ohm's law, V is equals to IR. So I will be equals to the EMF divided by the total resistance of the circuit. So that will be the EMF of the cells is 6 volt, and the total resistance of the whole circuit, we have just calculated that, that is 40 ohm. So 6 divided by 40, and that will be 0.15 ampere. 0.15 ampere. That is the current which will come out of the battery. Okay, so we will move to the next part, and the next part is, they say, the current supplied by the power supply. We are done with that. He says the potential difference across the 20 ohm resistor. So the potential difference across the 20 ohm resistor. So we want to find out how much is the voltage drop or potential difference here. So first of all, I will find out, because I know how much current is flowing through the circuit, the whole current will be flowing through this 24 ohm. So if you know the resistance of this R3 and you know how much current is flowing through here, I can find how much is the voltage drop here. Once you know the voltage drop here, then from the EMF, subtract that voltage drop, the remaining voltage will be provided here. So that is the strategy of doing this question. It's a 2-mark question. So let me show you my work. Okay, so first of all, I will find out how much is the voltage drop on the resistor 3. Resistor 3 is 24 ohm, and the current flowing through that is the current which came out of the battery. Same current will go back to the battery, and that is 0.15 ampere. We just calculated in the previous part. So 0.15 multiplied 24, and that will give you 3.6 volt. It means that the 24 ohm resistor has a 3.6 volt potential difference. So the battery or the EMF is providing you 6 volts, and 3.6 volts are used by the 24 ohm. The remaining voltage, which will be equals to 6 minus 3.6, that is 2.4 volt, because the 20 ohm resistor and the 80 ohm resistor, they are connected parallel to each other. So both of them will have the same voltage drop. So the voltage drop across the 20 ohm resistor will be 2.4 volt. I hope you understand. So that was the B part. Okay. Now question number 10B, and its second part, he says, we are done with the first part. Okay. The DC power supply is a battery that contains a number of cells. Each cell has an electromotive force EMF of 1.5 volt. State what is meant by the electromotive force EMF of the cell. When you connect the voltmeter directly with the terminals of the battery, the reading given by the voltmeter, when you have connected its wires directly with the terminals of the battery, that is known as the EMF of the cell. The very famous definition, which is also in your book, is that the electromotive force of a cell means the work done by the cell in moving unit charge in closed circuit. EMF is the amount of work done by the cell on the unit charge to move it in the closed circuit. So that is the definition. It's a 1-mark question. So let me show you the marking scheme. I mean the written answer which I have written. EMF is the amount of work done by the cell or by the battery to move the unit charge around a closed circuit. So that is the definition. Okay, so let's go to the next question. He says, that's the second part. He says the space below, draw a diagram to show how 4 of these cells are connected to make a battery of EMF 6 volt. Mark the positive terminals of the battery. So let me show you. If you have 4 cells which are each of 1.5 volt, and you want to get 6 volts, so you will have to take 4 such cells, and the negative of one is connected with the positive, the negative of the second is connected with the positive of the third, and the negative of the third is connected with the positive of the fourth. So this is how your cells are arranged. Each cell is 1.5 volt, but when you connect them in series, like I have shown, and then their EMF is added up. So the 1.5 plus 1.5 plus 1.5 plus 1.5, and that will give you 6 volts. So this is how you will show. Okay, so this is question number 10, and it's B part and second portion. Okay, then he says, in another arrangement to produce a battery of EMF 6 volt, 8 cells of the EMF 1.5 volt are connected in this arrangement. Some cells are connected in series and some in parallel. In the space below, draw a diagram to show how the 8 cells are connected to make the battery. Okay, so let me show you. It's a 1-mark question. So this time you have 8 cells, and you can see I have connected in like this. So 4 cells upstairs, 4 cells downstairs. They are connected. The 4 are connected in series to each other. The lower in the lower branch, the 4 cells are connected in series to each other. But basically, they are parallel to both the branches. This branch and this branch, they are parallel. So this here the EMF will be how much? It will be 6, and here the EMF will be 6 because they are parallel. So their voltage do not add up. So here you will getting the voltage of 6, but you are using 8 cells now. So the positive terminal will be this one where this length is shown longer. That's the positive terminal. Where this length is shown shorter, that is the negative. So this is the positive terminal, and this is the negative terminal. So that is question number 10B. And okay, so that was the question number 3. I mean question number 10 is second part, B second part, I mean. Okay, so the question number 10 and its C part is, he says, state one advantage of using a battery made from cells in parallel rather than a single cell. You see, when you use 2, 3, 4 cells parallel to each other, their EMF do not add up, but their life becomes longer. The cells will last longer. The, the cells will have a longer life. So 1 mark question. So let me show you from my answers. Okay, cells in parallel last longer. So let's have a look at the marking scheme, what the marking scheme says about the question number 10 and its B part. So question number 10 and its B part is showing up on your screen. He says, and the C part is also showing up on your screen. So what you can do, you can pause the video and take your time and compare the answers which we have done with the answers shown here. So hopefully you have taken your time, you have paused the video and you have looked at the marking scheme and noted down, compared the answers which I gave to you with the marking scheme. Okay, so let's move to the next question. The next question coming up on your screen is question number 11. He says, one source of background radiation is cosmic rays. The cosmic rays that enter the Earth's atmosphere are known as primary cosmic rays. Most of these rays are fast moving protons or fast moving alpha particles. Both the Earth's magnetic field and the Earth's atmosphere reduce the number of primary cosmic rays that reach the Earth's surface. Name a source of background radiation apart from cosmic rays. So there can be many sources of the background radiation. For example, there might be some ore or minerals in the soil in that area which are radioactive, so they will be giving out radiation. There might be some nuclear testing going on around that area, so that also causes radiation, background radiation. And there can another problem actually, that some the you see the fuel of the power nuclear power station, that waste fuel with the fuel which has been used, but is some of that is left, the wastage of that fuel, that is supposed to be disposed of somewhere safely, but it gives out radiation because it is radioactive. That fuel waste from the nuclear reactor, that can also be the cause of the background radiation. You only have to name one source here. So let me show you question number 11. He says, I have written answer. I have only written here only a single source: waste from a nuclear power station, that can cause the background radiation. Okay. So the next part, he says, state one effect of the background radiation. You see the background radiation, which is all the time present around us, and that background radiation can cause ionization. That background radiation can cause a mutation of the cells. It can cause the cancer in the body. So only have to you have to only mention one of the. Okay, background radiation. I have written that the background radiation can cause cancer. Okay, so let's move to the next part. And he says, third part, he says, state the number of protons and number of neutrons in an alpha particle. You know, the alpha particle is like the nucleus of helium. Alpha particle is like the nucleus of helium. It has 2 protons in its nucleus. It has 2 neutrons in its nucleus. So alpha particle is like helium nucleus. It has 2 protons and 2 neutrons in its nucleus. So let me show you my answer. So the protons will be 2 and the neutrons will be also 2. There will be 2 protons and there will be 2 neutrons in the nucleus of alpha particle, which is like the nucleus of a helium nucleus. Okay. So another question coming up on your screen is, he says, we are done with that. He says, explain how the Earth's atmosphere reduces the number of alpha particles that reach the surface. You know, the alpha particles, their penetration power is very low, their ionization power is very high. So alpha particles, when they enter into the atmosphere, they are absorbed by the atmosphere, or you can say they are scattered by the atmosphere. So let me show you my written answer for the fourth part. And it says alpha particles are absorbed by the atmosphere. Alpha particles are absorbed by the atmosphere. So let's go to the next part. So this is the fifth part. He says figure 11.1 shows an area where there is a uniform magnetic field into the page. And on the figure 11.1, draw a diagram to show the deflection of an alpha particle by this magnetic field. So let me show you. Let me switch on the camera so you can see. Okay, so let me change the direction of the camera. So for example, here the magnetic field is into the page. So see, the magnetic field is into the page, and we will have the alpha particles. The alpha particles are positively charged. So I will use the left hand. So this is my left hand. I will stretch my fingers of the left hand. So this thumb is the direction of the force. This index finger is basically representing the magnetic field, and this middle finger is basically representing the direction of the positive charges. So the index finger is pointing towards the screen because the magnetic field is into the page, and you know the direction of the current is going from left to right because the alpha particles are going from left to right. My thumb is pointing upward. My thumb is pointing upward. So what will happen? The alpha particles will be deflected upward. So this is how you will apply the left hand rule. This is how you will stretch your fingers. You can see this is my left hand, and this is how they are mutually perpendicular to each other. This one is representing the direction of the force. This one is representing the magnetic field. This one is representing the direction of the current or the charged particles. And this is about the positive charges. Alpha particles are actually positively charged. So I know that the alpha particles will be deflected upward. So this is how you will show that how, in which direction the alpha particles will be deflected. Okay, so let me show you this is the question number 11A and its fifth part. And on your screen, I have shown the alpha particles, and this is how they will be deflected in the upward direction. I have used the Fleming's left hand rule to find that in which direction the alpha particles will be deflected when they enter into this magnetic field, which is into the page. Hopefully you understand that how I have used the left hand rule, Fleming's left hand rule, to find the direction of the deflection. So that is question number 11A, fifth part. So we are done with the question number 11 and its A part. So let's have a look at the marking scheme. So you can see on your screen, question number 11, A part, its marking scheme is showing up. Pause this video and read this marking scheme carefully. It is very, very important. Okay, it's very, very important to compare the answers which you have, your teacher's answer, your mentor's answer, your class fellow's answer, your own answers, compare them with the marking scheme. It's a very, very important practice. Okay, so let's move to the next question. I mean, the next part, question number 11, and it's B part. It says primary cosmic rays produce carbon 14 in the atmosphere. The half-life of the carbon 14 is 5,700 years. Define the term half-life. Half-life is basically the time period in which the 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 activity rate of a radioactive sample will become half, or you can say it's the average time duration in which the half of the atoms or molecules of a radioactive sample, they will decay. It's a 2 marks definition, very important definition, very famous, frequently asked in the Cambridge exams. Okay, so average time in which half of atoms of a radioactive isotope decays is known as half-life. So remember this definition word to word. Okay, so let's go to the next part. He says a specimen of wood is found to contain 25,000 atoms of carbon 14. An otherwise identical specimen taken from a living tree is found to contain 200,000 atoms of carbon 14. Determine the age of the specimen that contains 25,000 atoms of carbon 14. So I will use my grid and I will find how much time has passed. And so here we go. So at the start, you have 200,000, and when one half-life has passed, this will become half, 100,000. Another half-life pass, this will become half, it will become 50,000. Another half-life will pass, and you will have half of this, you will have 25,000. So there are 3 half-lives pass, so the time is equals to 3 multiply half-life, so 3 into 5,700. So you will get 170 no 17,100 years. So the sample is 17,100 years, because there are 3 half-lives past and each half-life is of 5,700 years. Hopefully you understand this numerical. Okay, so let's have a look. He says, state why it is not possible to use the amount of carbon 14 to date a specimen that is 570,000 years old. So this is too much duration for the carbon 14, because during this duration, the carbon atoms which will be left in the sample will be very, very few. A minute trace of that carbon 14 will be left, so that cannot be analyzed then. So that's why we cannot use the carbon dating of that old sample. Okay, so let me show you my answer. So it says too little carbon 14 is left in the sample after 570,000 years. Okay, so question number 11, and it's B part. We are done. So on your screen, my dear students, question number 11, it's B part marking scheme is showing up. So pause the video and have a look at the marking scheme of question number 11 and B part. It is very important to all the time compare the answers which you have written or which you have learned from your teacher. Compare those answers with the marking scheme and it will actually improve your answering skills. Okay, so let's move to the question number 11 and C part. And here we go, question number 11, C part. It says carbon 14 is one of the isotopes of the carbon. Another isotope is carbon 12. Describe how a nucleus of carbon 14 differ from a nucleus of carbon 12. You see, because they both are isotope of each other, so they will have different number of neutrons in their nucleus. So carbon 14, it will have, I think, 8 neutrons, and carbon 12 will have 6 neutrons. And so that is the difference between their nucleus. Then he says, describe one similarity in the structure of the nuclei of these isotopes. Both these isotopes, they will have the same number of protons in their nucleus. So that's the similarity. So let me show you my answer first of all, and then. Okay, so carbon 14 has 8 neutrons, while carbon 12 has 6 neutrons in the nucleus. So carbon 14 will have 2 more neutrons in the nucleus as compared to the carbon 12. Carbon 14 has 6 protons, and carbon 12 also has 6 protons in the nucleus. That's the similarity between them. So, my dear students, by this question, we have reached the end of this paper. So let's have a look at the marking scheme of this question number 11 and its C part. So this is the marking scheme. You can pause the video and you can take your time and read and compare the answers with the marking scheme. So thank you very much. Today we have done remarkably, we have completed the section B of this paper. Today we were working on the May-June 2017 Physics 5054222 paper. And in this video, in this session, we are done with the section B. The section B was question number 9, question number 10, question number 11. The section A of this video, this paper, I have already done, and I have uploaded that video in my YouTube channel in the same playlist where you find this video. You will find that video also, the section A of the May-June 2017 2-2 paper. So I hope that this video will help you to improve your concepts of physics and improve your skills, the answering skills in the for the physics exam. So thank you very much. If you find this video interesting, and if you find this video informative, if this video is helping you, please share the link of this video onto your Facebook, into your Instagram account, and onto your Twitter accounts. Also subscribe my channel, because when you subscribe my channel and you like this video, it helps me to you know to improve my work. It also helps me to promote my channel. So thank you very much, everybody. It was a great pleasure for me to teach you online. Special thanks to all the students who are in different countries. They are in Pakistan, they are in India, they are in Bangladesh, they are in Mauritius, they are in Zimbabwe, they are in Saudi Arabia, they are in UAE, they are in Brunei Darul Islam, they are in Burma. So so many people around the world are watching these videos. So it's a great blessing for me to do this work. So thank you very much, everybody. Have a good day, and God bless you all.